In this video we shall discuss data logical modeling techniques and tools. On data logical level we have to deal with a lot of technical details, so we may use data specifications in rare cases, but nevertheless, for instance for some binary formats and so on. We may use special formats, for instance for NoSQL databases, that's the common case, and of course we may use graphical representation as schemas. Those schemas are usually UML ones and they may look like this. So we have a lot of technical details here, like data types, like information about primary keys, foreign keys, indexes, operations, relationships, and so on and so on and so on. All these are the technical details we are dealing with on data logical modeling level. In order to be successful with data logical modeling, we have to get some knowledge. And we may review two situations, an ideal situation and so-called minimal situation. Let's start with the ideal. We have to deeply understand relational theory, deeply understand normalization, deeply understand SQL, have deep knowledge of our selected DBMS and have deep knowledge of our modeling tool. So we have to have deep knowledge. But that may take a lot of time. So at least we have to basically understand relational theory, basically understand lower forms, basically understand SQL, basically understand our DBMS, and basically understand our modeling tool. So we have to have basic knowledge. But of course we have to make efforts to move from basic knowledge to deep knowledge as quick as possible. The next thing that will help us with data logical modeling is conventions, DBMS conventions and database conventions. DBMS conventions include DBMS type, so what type of database are we dealing with, what particular DBMS are we dealing with, what's the minimal version of our DBMS, because the information about version leads us to understanding of some limitations and capabilities of our DBMS. We also have to know some infrastructure details, like is it a single server or is it a cluster of servers, is this a physical server or this is a cloud server, and so on and so on and so on. And of course we have to have some DB conventions, like structure naming, SQL code formatting, commons principles, and other specifics like API with, for instance, stored procedures, and so on and so on and so on. This information will extremely help us with improving the technical usability of our database. Most DBMS developers provide some specific tools for their DBMSs. For MySQL, we have MySQL Workbench. For SQL Server, we have SQL Server Management Studio. For Oracle, we have SQL Developer Data Modeler, and so on. But there is an alternative. We may use some other tools. We may use universal tools like Sparx Enterprise Architect, DB Schema, DB Diagram, and so on. And you may have a question. If we have all those specific tools, why do we need these universal tools? There are several good reasons. With universal tools, you almost never directly manipulate your database, so you have almost zero chance to break your database. Believe me, in life of almost each and every database developer, there comes a day when he breaks live database, and that's a terrible mistake. So, no direct manipulation, zero chance to break something. Universal tools support multiple DBMSs, so it's easy to compare several schemas, to convert schemas from one DBMS to another, and so on. We have a lot of opportunities here. As long as many specific tools has a lot of weak spots, something that users do not like, the universal tools try to eliminate those weak spots to compete with huge specific tools produced by DBMS developers. And usually universal tools have more user-friendly interface, better support, bigger community where we can ask questions, get some support, and so on and so on. And in the next video we shall review data logical modeling example using some tools.